Hello YouTubers! Today I plan to install a chuck, a 120mm chuck in my old lathe, and of course we have a backplate that's not been drilled yet. So what I plan to do is to show you how I'm drilling the backplate using the DRO. Chuck is here, backplate is here. To measure the distance and to measure the correct position of the three holes. To find the correct position of the three holes, I inserted 3 screws, and I'm writing down the dimensions. So it's 12.77, 12.76. I'll write it down on a whiteboard. The second one,
12.71. 12.73.
now the distance between 2 consecutive screws. One 105.9. Next ones. So this is the chuck backplate, the holes. We measure the distance between 2 consecutive holes, and I took an average like 105.96. So to find the distance between the holes diameters, we have to subtract the average OD of the screws. So between 2 consecutive 2 holes centers, we have a distance of 105.96 minus 12.73. It's 93.23 force millimeters. Yeah, so we actually have an equilateral triangle with 93.20 with a side of 93.23 millimeters. The distance between the center and the middle of the hole, it's actually the radius of the circle circumscribed in this equilateral triangle. That means the radius is let's say let's say this is L multiplied by 3 radian, divide 3 radian divided by 3, which is 93.23 divided by, it should be 1.73, I don't know, divided by 3. I'll make the math using a computer, and I'm not sure that 3 radi is 1.73. Okay, I'll show you. Okay, so the final result of the radius is 53.82 millimeters. So the plan is to indicate the middle of the backplate using the milling machine. Maybe I don't know how I will do this, but I will indicate the center of the hole in the milling machine and then use the DRO function of the milling machine to find the exact position of the 3 holes. Let's go to the milling machine now. To indicate the center of the backplate, I'm using the dial indicator. I will put some grease on the finger of the indicator. I'll put some oil, I'm sorry. Okay. We are in the center now. Okay, so this will be our DRO 0 center. We'll zero the DRO now. Of course, I only need the X and Y axis. I don't care about the Z axis of the DRO. Let me turn the camera on the DRO now. We are now in the center of the part. The DRO is set on x-axis to 0, on y-axis to 0. And we'll be using the PSD function. It's asking us to select the plane first. Of course, the plane has to be this one, x and y. The position of the center of the circle, it's the center of the arch that is defining the holes, is 0. The diameter of the circle, we have to multiply 53.82 millimeters by 2, which was the radius, yeah. So the diameter is 107.64 millimeter. Next step is asking for the starting angle. I choose, because I clamp the part on the table right in the middle. I cannot use 0 degrees, so I had to select 90 degrees. So our starting angle, the first hole will be set up at exactly 90 degrees. So the second hole is it has to be 90 plus 120 is 210 degrees, and the third hole, the last hole, will be set up at 210 degrees plus 120 degrees, which is 330 degrees. Yeah. So the third, the end angle, the third hole and the last one will be set up at 330 degrees. Of course, the number of holes, it has to be 3. So the DRO is asking us to move for the first point, for the first hole, we have to move the table to 0 on X and Y axis. So this is gonna be our first hole, and let me put the camera on the part now. I will mark the holes first, and in order to check them later if the DRO was correctly set. In order to counterbore the holes, I will use the 9mm counterbore. I will use the 9mm drill, sorry, in order to be used on this counterbore. So let's do the first one. For cast iron, I'm not using any oils to lubricate the part. I consider not necessary on this speed. For the second hole, we have to align again X and Y axis. So here will be our second hole.
to pull close to the bottom of the hole. When I go to the bottom of the hole, I don't want to push harder on the wheel, because otherwise the material will be destroyed. So I'm pushing as gentle as I can. I want to go deep, 48.3 millimeters. We'll sort of make it a number.
I'm very touching the edges for deburring. I'm deburring now the bottom of the hole. I'm taking the part out to show you the final result. From the bottom of the holes it has to be deburred, but the cast iron is not damaged, so the drill was coming out very easy. So from inside, holes looks perfect. Yeah, they fits perfect. If you enjoyed the video, please subscribe. Thanks for watching. Bye, YouTubers.